everyone. So in this presentation, we will explain our final exam project for the computer network course. Before we explain, let we introduce ourselves first. My name is Dinda Marta with student ID 2415101054 and my friends.
My name is Kenia Regatha Siahaya with my student ID 2415101073.
Okay, the first thing we should explain is about determine the values of the A and K fee. Okay, in here we use the name, the student ID is 2415101073, and we use the two last digits, the ID is 73. For the calculation, the N is we use 73 mod 64 is equal by 9, and then uh, K is calculated is as 4 times N, so the K equals 36, and then the V is obtained from N modulo 5, which is gives us V equals 4. Therefore, in here we have V equals 4 scenario. Next, I will explain about the IP block and the address. Based on the calculated value of the K, the main IP block used is 10.60.k.0/22. This subnet provides a total of 100 to 24 IP addresses, which is sufficient for all LAN segments and router-to-router connections. The subnet mask used is 255.255.252.0, and then with the network address starting 10.60.36.0, and the broadcast addresses is 10.60.39.255. Okay, in here, this is our network design. This is uses three routers here, and then each routers has two LAN segments. This is the two LAN segment of each routers. And then this design forms a full mesh topology between routers, which increases reliability and ensures multiple communication paths. The design analysis here is the router one here is handles two LANs. Router zero also has handle two LANs, and then the router 2 handles two LANs. Each LAN is represented by one PC and one switch in Cisco packet tracer, since the actual number of computer is already represented in the API calculations. The inter-router connection use slice 30 subnets because point-to-point links only require two usable IP addresses. And the next explanation will be present by my friends.
Alright, so moving on to the subnets of the routers, we have 30 types of subnets because we have three routers. Starting from the number 1, which is from router 0 to router 1, vice versa, we start from 10, 60, 38, and 65, and router 0 using a serial 2/0, and onto the router 1 using the 10, 60, 38, and 73 address using the router 1 using serial 3/0. And then the second one is router 0 to router 2's, vice versa. We have 10, 60, 38, 69 using the router 0 using serial 3/0 to 10, 60, 38, 70 in router 2 using the serial 2/0. And then the third one, we have router 1 to router 2 vice versa from 10, 60, 38, 66 in router 1 using serial 2/0 to 10, 60, 38, 74 in router 2 using serial 3/0. Next. Now, because we uses the fee that is 4, we uses these kind of segments. We name those segments account administration network that has 5 computer amounts and the backup 25%. Therefore, this will give us the backup IP amount of 12. And the IP needed total is going to be 57 after we have calculated all of this by calculating the percent multiplied by the computer amounts, that we will get 11.25, which is, if we run it up, we will get 12. Therefore, 45 plus 12 equals to 57. Same thing also goes from segment 2 to segment 5, which is segment 2 we have lecturer office network that has a computer amount of 35 with the backup presentation of 20%. This will get us 7 backup IP mounts, but the IP needed total is 42. And segment 3, we named it as Student Computer Laboratory with a 72 computer amount and backup presentation of 30%, with a backup IP amount of 22, and we will get the IP needed total as 94. Segment 4 is Library Network, which has 12 computer amounts and then backup presentation of 40% with IP amount of 5, and we need IP amount of 17. And then segment 5, we have Administration Server and Network, which has a computer amount of 100 and backup presentation of 20% and a backup IP amount of 20 and IP need total of 120. This means the segment 5 is the largest segment we have. Next. Therefore, because we have 5 as the largest segment, we can order it from 5, 3, 1, 2, 4, 6 with a descending order, meaning we are the largest to the smallest. So in segment 5, which is Administration Server Network, we have PC4. And then we can see that we use the IP of 120 with the IPv4 address is 10.60.36.2. We use the prefix subnet of /24. The subnet mask will be 255.255.255.0 with the default gateway of 10.60.36.1, and the usable range is from 36.1 to 36.254. And then the broadcast access is going to be 36.255, but the total usable is 254. The next one is the third segment, which is Student Computer Laboratory. We have the address of 10.60.37.2 with a prefix subnet of /25. The subnet mask is just different on the back, which is 128. If the last one is 0, then this time we have 128 with a default gateway of 37.1 with the range from 37.1 to 37.126. And then the broadcast address will be 37 and 122 with a total usable of 126. And then the third one is the first segment, the segment 1, which is Academic Administration Network. And we have the subnet mask of 192 and then default gateway of 129, ranging from 129 to 190. 37, 190. And then the broadcast address is going to be 37, 191 with a total usable of 62. And then the fourth one, which is lecture office, we have subnet mask of 192 with the default gateway is 38.1, ranging from 38.1 to 38.62, and the broadcast access for 38.63 with the total usable of 62. The fourth one is Library Network, which has the subnet mask of 224 with the default gateway from 37.193, ranging from 193 to 222. But the broadcast access is 37.223 and usable of 30. Then we got the backup, which is the sixth segment we use as backup, which is in PC3. We have the address is 37.226 with a subnet mask of 240, 240, and the default gateway from 37.225, ranging from 37.225 to 37.238. And then we have the broadcast access of 37.239 with a total usable of 14. Now, after this, we will continue with the demonstration of our network over here. Okay, so here we have our network here. We can see that this is the Academic Administration Network, lecturer, and the rest over here. So in our simulation, I'm going to be pinging from PC0 to PC3 and 4, and PC1 to PC2 and 5. That is going to be our simulation. Okay, so as we can see, everything has been pinged and the packets are all delivered successfully.
Okay, I think that's all our explanations about our final exam projects. And thank you. Goodbye.